Assalamu alaikum. So this is an astable multivibrator circuit from which you can easily get the square wave, and this is the circuit diagram for this astable multivibrator circuit, and the mechanism of this circuit is very interesting, and I will inshallah explain how this circuit works in some other video. But in this video, let's say you want to quickly make this circuit, so which things you should consider. Okay, so let's start. So first of all, you see this resistor is RB and this resistor's resistance is RC, and you have to choose this RB. You have to choose this RB many greater than RC, and this value is important because this value adjusts the time period of this square wave. So we will talk about it later in here. You see, while finding the time period you have to use RB. We will talk about this later. The next question is, sometimes you will see, while if you understand the mechanism of this circuit, you will see that sometimes this point's voltage is positive and sometimes this point voltage is positive. But you have, let's say you have this kind of electrolytic capacitors. You see, I have used here electrolytic capacitors. So you see, one leg is taller and another leg is shorter. So you have to apply a positive voltage always to the positive terminal. But here sometimes this point is positive and sometimes this point is positive, so it's not possible to apply positive voltage always to the uh, taller terminal. So what can we do? And that's why we connect two capacitors in series, and we connect two taller parts or two positive parts or two anode, actually two taller parts together and connect it in series. And that's why these two capacitors are in series and making this one single capacitance. Similarly, these two capacitors are in series and making this single capacitance. Okay, and as these two capacitors are of 100 microfarad, so if you connect it in series, you will get actually half, I mean 50 microfarad. If you know the formula for equivalent capacitance of series capacitors, you can easily understand that the equivalent capacitance is 50 microfarad. Okay, so now what is the time period of this circuit? So what is the time period of this circuit? The formula for which one LED will stays on, for one LED will stays on or one LED is glowing, the time duration for that is ln to RB into C. So RB is simply 33K, you see I have used here, and C is 50 microfarad, not 100 microfarad, because 200 microfarad capacitors are in series and equivalent capacitance is 50 microfarad. So the time 1.14 second, this is the time for which the output voltage is high, and another 1.14 second the output will be low. That means total time period is double of 1.14 second. That means 2.28 second is the time period. So time period is actually 2 into 1.14 second. Okay, and now let me tell you one interesting thing, that how our human body is affecting this circuit, how our human body affect the capacitance. Actually, you see I am touching this capacitor and you see something is happening, right? And now let's touch here. Now let's touch here. You see, now the green light is glowing for a longer time. So our human body is affecting this circuit actually. So put your finger away from these capacitors. So thank you.